What we're looking to do here in number 5 is to determine if this matrix here is stochastic. So a stochastic matrix is a matrix for which some power of itself has all non-zero entries. So we'll look at this matrix here. Our matrix here is T, and this matrix is down the columns 0.8, 0.2, 1, and 0. So what we've got here is that T to the first, okay, that's not a prime. That looks, let me fix that. This looks like I want T to the first power. T to the first has some 0 entries. But that doesn't mean that it's not stochastic. T is not stochastic. Let's take a look at T squared. So I put T into my calculator and I squared it. And when I squared that, here's what I got. Down the columns I got 0.84, 0.16, and then I got 0.8.2. Now, in T squared, right, some power of T, we have all non-zero entries. So we're going to conclude now this. We're going to say that T is stochastic. This matrix here is stochastic since the power of T, in particular the second power, contains all non-zero entries, right? So a matrix is stochastic if some power, like the second or third or fourth or whatever power, contains all non-zero entries. So if you can take this matrix and keep raising it to subsequent powers, higher and higher powers, and get rid of all the zeros, then T is going to be stochastic. And we had to raise ours only to the second power to eliminate all the zeros.